what is it that we are using here, how is it that is connected with the concept of ESS we discussed earlier. Now, the question which she asked, to make it more precise for everybody, she was saying, when we were discussing earlier, we were discussing about a U matrix where you had actions, and now suddenly when we write replicator equation, we are talking about frequencies. So, what is this matrix at all? Because there, when we are calculating expected fitness, we are calculating using the matrix U and multiplying it with the probability over actions, that is the mixed strategy. And there we defined ESS and everything. How suddenly is that we are treating this on the same footing by now treating frequencies as sort of mixed strategies? So, how is that happening? That is the question. Okay. So, it is a technical catch here, and so this comes under a topic called strong stability in maths. So, see what is it that you are doing. When you had several pure actions, you had player 1 playing against player 2. You can have many. We worked with 2 by 2 matrix, didn't have to be, as many as pure actions could have been there. Once you have all those actions, what are those actions? Those are, in evolutionary or biological terms or cultural terms, those are traits. We discussed that there is possibility of mixed strategy traits as well. What does that mean? Is that if I write these actions in the space of simplex, then essentially I am saying the pure strategies are lying somewhere in the corner. I cannot draw n dimensional simplex, right. So, it is just representative of a simplex, where I am saying the probabilities are lying on a space where the probability of S1 will be here, probability of S2 will be here, S5 will be here, all that, and those are going to be pure ones, because the probability vector corresponding to strategy S1 is going to be 1 0 0 0 0, for 2 is going to be 0 1 0 0, for 3 is going to be 0 0 1 0. So, those are corners on the axis, but you have other mixed strategies possible. What are those? Any possible point on that simplex, right. So, you have many actions possible. How many? Uncountably, infinitely many actions possible. Now, suppose I take 2 of them, I could take 3, 4, 5, whatever. Let us take 2 of them, and I ask that I have a population where I have 2 strategies only, Si and Sj, and I am talking about their frequencies. Okay. So, now my question is, I draw a matrix, is all formality, I draw a matrix, I write down the actions, but now my question is that if an arbitrary individual with S1 strategy is picked and it meets with an individual S1, what should I put in here? Given I know U matrix, this is U11 dot dot dot.
What is that simplex that you?
It is just a space, abstract space, where all the probabilities are lying. You see, this is these are 4 strategies. So, my probability will have 3 independent components. So, my space will be 3 dimensional, right. So, it is a 3 dimensional object where all the probabilities can formally lie. I mean, if it does not help you, do not think about it, just think that I could choose arbitrarily any probability over these, any probability distribution over this support. I could have always picked, and that would be a valid mixed strategy. And in biology terms, that is going to be one kind of a behavioral trait. I can pick as many as I want. I am picking 2. And I am asking the question, I have a population of those 2 traits which appear with fraction x1 and xj, and I want to know that how do they evolve. But to do that, I have to calculate these. That means now I am asking that when a guy which I picked from here, how much that guy is going to get when it interacts with one of the opponents inside, which means what should I put in here? That's the answer. So what should I put in here? Because I already know what P corresponds to this SI. There will be some P which will correspond to this SI. Something. There will be P1, P2, P3, P4. There will be some Q, let us not use Q, we are using Q for mutants, some P2 or Pi, or now it will become too much complex. I think let us put P prime. There will be some P prime corresponding to the second one. Now you are asking, when P interacts with P, what is the fitness? We already know the formula. It should simply be P dot U P. Is this statement clear? Is the setup okay? So similarly, what is this going to be then? P U P prime. This will be P prime U P, and this will be P prime U P prime.
So why don't we use Q? Because
oh no, because it will confuse, because I use Q exclusively for mutants.
yeah, but
This is not mutant.
but this SJ can also be seen as a mutant.
No, that's what sort of I explained. When I am working with replicator, I am keeping no provision of mutants appearing. I am starting with a setup where I am saying that I have what I have. Now how they evolve. So that's the only reason. But of course, I mean, how it came has to be through mutant.
So this is like this is between my strategies only.
Yes. I don't know what is my strategy now. This is among these players.
But you said there is no mutant.
No. Don't confuse mutant. Okay. When I come here, who is mutant? Why are we even talking about mutant? I just said that you have two traits. Whom should I call resident? Whom should I call mutant? No point talking like that. Right? So this will be a. Now what has to be shown is the concept of ESS which we developed. If it works with this matrix, it is compatible with the definition of ESS which we created using strategies. If I can make that correlation, then this makes sense. Otherwise, everything is messed up. Okay. So now I am going to do that connection. But if you have confusion here, clarify it here, because otherwise connection wouldn't make any sense anyway.
So when you say frequency of what?
So black colored people, white colored people, 50% black, 50% white, frequency.
A also will be if there are n strategies, n into n cross only.
No, that's an important point you have to remember. The dimensionality of this has nothing to do with dimensionality of this. This has been created by what kind of populational traits you have. Okay. It can be as many as you want, as few as you want. So the dimensionality need not match. All you are doing here is you are using this to define which traits you are interested in and what is the fitness of those traits. There is some underlying matrix from where you are extracting it. Your definition of ESS was through this, but now suddenly we are using this A. So I have to show that somehow there is connection between that formalism and this formalism. Those frameworks sort of give you same consistent result.
What is P prime and P and P prime again?
So black colored people appear with probability P, and white colored people appear with probability P prime in that sense.
So are there numbers?
Depends on how you are defining your trait. If your trait is a mixed trait, then it cannot be a number, it has to be a vector. If it's a pure, then it can be a number.
Like let's say like I mean this doesn't make sense there. Let's say like I have 1/3 probability of being black or 2/3 probability
Yes,
of
yes,
being white.
yes.
So that will be my P,
That will be your P.
and that is corresponding to one X.
Nothing here right now. That will correspond to, in this case, that will only correspond to that you have that strategy, that's all. Now you are saying I have a population of those strategied guys. That is the fraction xi. Okay. So don't confuse between P and X. That is the confusing part here. There is P, there is X. What is it that I am working with?
So X is the population of people who have that strategy.
Fraction of people who have that strategy, yes. But the strategy itself has been created using P. That is not fraction.
So U is the payoff matrix.
U is the underlying payoff matrix, through which payoff you can get the payoff elements of your chosen traits. I don't know what U is.
So chosen traits are like what's the relation with the strategies?
Yes. So, for example, you can have, let's say, mixed strategies are possible. Okay, and I can have brown people, white, black, and yellow. 4 kinds of human beings, and the mixtures are also possible, right? I am asking a question. Those I am calling S1, S2. Now I am asking a question. If mix was also possible, there is a country where there are 2 kinds of people. One kind of people are 50% yellow, 50% black. Other kind of people are 40% black, 60% white. Only between those 2 traits, what is the evolutionary dynamics? That basically constitutes this. So I need to create that A.
So what we call the A matrix.
It's just A matrix. Well, it's a fitness matrix also for that particular, for these 2 competitions.
All the SIPs.
Huh. Yes.
Sound like and that is
It will just become trivially easy. If you only work with, what you are saying is this: if I take only the pure strategies and I talk about their fractions, then this will trivially become this matrix. It is not trivially this matrix once we start including the mixed strategies. In fact, you could have worked with only 2 of them and talked about fractions of S1 and S2, it will just become this block there, trivial. The complication is coming because of the mixed strategies. Is the setup clear?
Yeah. So the P's are basically in this for this particular example the 4 component vector.
Yes.
Whose components
Mixed strategies. Yes, yes. Is notation clear more or less? So let's prove this. Let me prove this using this. Okay, let's come back here.
So okay, so then this A is defined for a particular pair I.
Pair or 3 or 5 or 6, yes. Depends, you choose.
Okay.
You choose your, which, I mean, you go to a population and you figure out what are the behavioral traits, what are their frequencies. That's what sort of A is. Right? So let me do it for, let me show you something for a very easy case. It is done in a book, it's easy. For arbitrary case, it just becomes very messy. Okay. So what I am doing is this. Let me write down this replicator equation for only 2 actions. If I write down replicator equation for 2 actions, my one equation will be this x, and the other equation will be with subscript 2, but because I am only working with 2 strategies, okay, I mean Si and Sj only, so I have only 2 of them. I really don't have to work with x1 and x2, I can work with x and 1 minus x. So the second one doesn't make sense, that will anyway come out. So I am not even going to use this 1. but here I have to, otherwise it is confusing, right, because this is the fitness of the first one. That is how I have to calculate. Now, there is an interesting thing, or rather not interesting, is just, so this can be written down as x1 ax1 plus x2 ax2, right. Now, x2 is nothing but 1 minus x1 and x1 is x, x1 is x. So, you can see this can be written down by taking 1 minus x common, and you are left with ax1 minus ax2. So, simple algebra gives you a simpler form for a case where you only have two of the strategies picked, just the way we have picked there, only two of them. Okay. Okay.
Why is x2 1 minus x1?
Oh, because we are working with only two of them, that is the reason. Fine. Okay. So, now I want to calculate these things. How have these been picked? This SI is nothing but, let us say, strategy P, okay, as we did. Using a standard notation, let me pick this as P cap, because I want to sort of argue, if this is ESS here in this setting, I am going to get correspondingly same behavior in the X setting. Okay. So, this is just notation for the timing, there is no point getting confused here. So, S will be denoted by this and Sj will be denoted by P cap prime. Okay. So, you pick those two. So, I want to now find these quantities here. I already know how those have to be found out. What is this? So, in my notation, well, wherever cap goes does not matter. No, this is not that, only primes will become caps, right. So, just a notational change. Fine. So, let us calculate this. What is Ax1? So, Ax1 is, you have the A vector and you have to multiply by x and take the first component. What is x? X 1 minus x. And what is your A matrix? A matrix is given there, that is P U P with vectors and all that, and P U P cap. What else is there? P cap U P and P cap U P cap, right. So, basically these are all vectors, these are all vectors and all that, fine, but a form like that. So, then what is the first component? This gives you Ax1 as P U P times x plus this times this. So, P U P cap times 1 minus x. So, first component done. I need the second component. What is the second component? Ax2, that will be this times this and this times this. So, that gives me P cap U P times x plus P cap U P cap 1 minus x. So, I know both the components. So, I am going to plug those components in here. Okay. So, let us plug the components. So, I have now x dot equal to x 1 minus x. Let me collect coefficients of x together right now. So, the coefficients of x, so please check if I am writing it correctly, this minus p cap u p plus 1 minus x times, it is a simple algebra, there is nothing much I am doing, it is just that I have not memorized it, so I cannot write it straight away. Okay with this? It's just, you can double check if I have messed up. Okay. So, now let us ask this question. Suppose I want to show that S j, which corresponds to P cap, is ESS. What would that mean? That would mean if my population has almost entirely Sj, almost entirely Sj, and little bit of Si comes, do I get back to all Sj kind of thing, or I go away from all Sj kind of thing? In mathematical terms, it says if x equal to 0, so what is, when is your population going to be all Sj? So, notationally this is x and that is 1 minus x, right, this is x 1 minus x. So, I am going to have all Sj if x equal to 0 is a stable fixed point. If my population is at x equal to 0, it means everything is Sj. If I perturb myself little bit away from s equal to 0 and I go back towards s equal to 0, that means my population of Sj is evolutionarily stable. So, I have to show now that s equal to 0 is actually stable fixed point, and I have to see when does that follow. Very easy. So, the dominating term here, you see there is only one term which is linear in x. Which one is that? X times 1 times 1. Every other term is cubic, quadratic in x. So, as x tends to 0, I do not worry about those terms, I only worry about the dominant term. That means the sign of this is going to decide whether my x dot is decreasing or increasing. So, when will x dot decrease? If this is negative, but look, this being negative is nothing but condition of ESS. Recall Maynard-Smith Price definition, right. By chance, suppose this is equal, then who is going to dictate whether x dot is going to decrease or increase? The next one, and this is exactly the second condition of Maynard-Smith Price.
Can you argue that first?
First one, I want to show that x decreases. Okay. So, if this has a form a times x plus, I call this terms too hot to handle, you have a form like this, this I can ignore in the neighborhood of x when x is very small. So, this a is going to decide whether x is increasing or decreasing. So, if a is negative, x will decrease. So, which is this a here in this entire equation? This x getting multiplied by this one and getting multiplied by this one. There is no other linear term here, and the coefficient of that term is nothing but this, and hence that term decides whether x is going to increase or decrease. I want that term to be negative, and if that is equal, then sort of this term is going to decide, and that is exactly the Maynard-Smith Price. So, what we have shown here is the condition of ESS given through the strategy space confirms with the concept of evolutionary stability given in the frequency space. And to make it sort of very strong, when you talk about ESS in the context of frequencies, you don't call it evolutionary stable strategy. You call it evolutionary stable state, because you are talking about population state. But luckily ESS has only one S at the end. It could be either state or strategy. So you can use the same abbreviation in both the cases, and you don't actually care about it, because this tells you that this actually doesn't matter. But this is very conceptual, that this is very important, that your definition of ESS, whatever it was, is actually being followed by whatever this replicatory equation is doing. Okay. Your population ultimately is going and settling down at a frequency which is at a mixed strategy whose frequency is given by x's. Okay. This also justifies that your replicatory equation is a very good equation. You want your evolutionary stable strategy to be actually dynamically stable as well. Otherwise, there is no point. It's just mathematical exercise. Well, it still is mathematical exercise, but then some maths are probably more maths than. Good. So that tells me I can work with replicatory equation, and this is that A. And now what has happened actually, you see, the beautiful thing is, these all space construction, this, that, using probability, and this space construction using this x are actually mathematically same, because these are also nothing but probabilities. The frequencies are probabilities, but here lies a very deep conceptual thing. These probabilities were subjective, these probabilities are objective. Okay. So what does probability mean is something we are going to discuss tomorrow when we will make connection with information theory. But right now, see it, just because I have a set of numbers who all of them are between 0 to 1 and they all sum up to 1, does not mean that that set of number is actually numbers of probabilities. But then if I can create a consistent set of numbers for me and I claim it follows Kolmogorov axioms of probability, then you cannot also deny that is not probability. See, if somebody asks me if is it going to rain or not rain, I am going to say, well, 50% chance is going to rain and 50% not going to rain, and the other guy says it's going to rain with 30% chance and 70% not going to rain. You cannot say your probability is probability, my probability is not my probability, and there exists something called true probability. There may not. That is the subjective probability. Okay. But frequencies is something which you are creating as ratios, right. If you have finite population, think about it, it is very odd. If you have finite population, ratios can only be rational numbers, and then you are not even working with enough probability numbers. It is only when you take your population to be infinity, you can get ratio whose limit points are going to be irrational numbers, and hence you can cover the entire interval from 0 to 1 using probabilities. That is one of the reasons when we are working in the setup of infinite population, we can actually talk about x being a number, any number between 0 to 1. If you are not working with an infinite population limit, we would never have x being any number on the interval between 0 to 1. It can only be rational. A natural number divided by a natural number is going to give a rational number. So it is a mathematical catch which we sort of absorb. I mean, practically we say x is so large, we can effectively take it to infinity. Okay. So these subtleties will come to when we will discuss information theory a bit, but this is sort of a teaser. So now coming back, I have this. There is a very important thing which we have to understand here, and these are sometimes called folk theorems of evolutionary game theory, because nobody really wrote it down. but everybody knows what the theorems are. And this is very easy to show. There are few of them, keeps on changing, but for us, for example, it is important to know that a Nash equilibrium is actually fixed point of this equation. Why is that important? If Nash is a fixed point, ESS will also be a fixed point, right? Unless something is a fixed point, it is very hard to talk about its stability. It is not that I cannot talk about, but sort of is going to be hard. Here we already saw that x is a fixed point. Look at it. If you saw this equation, we did not actually gotten into that. We started talking about its stability and all that. But is x equal to 0 even a fixed point? Yes, it was. And we talked about its stability. That should have been our first step. So we have to argue that the Nash equilibrium corresponds to fixed point of this replicator equation. Okay. What does Nash equilibrium mean here? Nothing other than a mathematical term. I have given you A, I have asked you find me Nash. A is even more complicated than U, not you, you. You are much more complicated. By the way, I heard that bananas have more genes than us, I mean, or something like that. If gene is the measure of complexity and intelligence. Okay, very easy to prove. I give you a matrix A and I ask you in the notation of, because you see x and p mathematically are same, right. So, I can use x as well to calculate Nash, and basically ask, this is the condition of Nash, right. I have a mixed strategy x, as if I have a mixed strategy x. Is this true or not true? That is what one has to check mathematically. So, let us go step by step. Suppose you have strict Nash, okay. Strict Nash. What does strict Nash mean? Only the greater than sign works. But you know, when do you get strict Nash? Only when Nash is pure, which means only when you have pure strategy is Nash strategy, only then you can have strict Nash, otherwise you can never have strict Nash, okay. But if you take a pure strategy, that trivially is a fixed point of replicator equation. How? Because all the xi's except one are 0. How many equations you have to actually write here? One less than number of x present, because there is the condition the summation of xi is 1. So, you design the equation to choose only those xi's which are all 0 for pure. So, automatically, because strict Nash has to be pure Nash, all the corner points in the simplex or all the this trivially is 0, and hence your strict Nash is a fixed point of replicator equation. Is the argument okay? So, if let us say you have x1 equal to 0 1, or you have, if this is Nash, let us say, then when you write down the equation, you will write down the equation for let us say x1 only, right. But this is Nash, and I am going to take the first component, plug it in here, this is the vector, sorry, and plug it in here, this is x1 and this is x2. So, this will become 0, only x dot will become 0, it is a fixed point trivially, okay. So, strict Nash trivially has to be fixed point. When you have weak Nash or mixed Nash, by the way, weak can also be pure, but let us come to mixed Nash, x dot ax equal to x dot ax. This will be the condition for mixed Nash, equal to sign. But this has to be, yeah.
This is for pure strategies, right?
Yeah, that's what I showed. I argued strict means pure and pure means 0 of the right hand side. Hence, strict has to be the fixed point. That's the argument. If it's mixed, there's something messy. And this has to be true for what? All x's. That is the definition of Nash. This relation has to hold for all x. So let's choose a particular x. Which particular x? A pure strategic x. I am not choosing Nash to be pure, I am choosing x to be the pure vector. So if I choose this x to be a pure vector, let us say the vector along the first strategy, then this is nothing but 1 0 in 2D, and hence this can be written down as x some I depending on which directional vector you took, right. So Ax i's are all same, I equal to 1, I equal to 2, I equal to 3, I equal to 4, all are same. We actually saw this already when we solved the hog-dove game, remember, while checking the first condition, the multiplication on the right hand side and the left hand side gave you exactly same 3 by 5, 3 by 5, 3 by 5. It is a general condition for any mixed Nash. Okay. If you knew this, I would not have even done that. Okay. So, this is equal to this, but if these two are same, you plug it in here or here. So, this is 0. So, fixed point. So, mixed Nash is a fixed point, strict Nash is a fixed point, every Nash is a fixed point. I do not know about stability. Nash need not be stable or anything. Under this dynamics, you could write other dynamics under which Nash will be stable. Think about this, this dynamics has nothing to do with rationality at this point. I could make some connections with learning and all, where in some limit this equation comes back, but at this moment the way this equation has been written, this there is something called logit equation and all, where there is a rationality parameter, and one can actually go on to show that when rationality is totally absent, this comes up, which makes sense. Nobody is thinking or doing anything, it is just selection process. So, there is formally, so that is what I am saying, it is formally that Nash is a fixed point. I give you a matrix, you find out Nash, that happens to be fixed point. Good for us, because that means ESS is a fixed point. Now I can talk about whether ESS is stable or not stable, right. So, it is at this point we have to sort of go ahead and find out that how to come up with a strategy of proving that ESS is actually going to be stable. Okay, so you ask questions if you have any at this point, then we will take the next jump. So, let me summarize maybe. What did we do? Actually, nothing much. All we said, there used to be something called classical games, and there are a lot of problems. There fortunately happens to be a research area where those problems can be put aside and you can earn your bread and butter. So, start doing evolutionary games. In evolutionary games, Nash will have no meaning. There has to be some other solution concept. The solution concept should match with evolutionary stability. You calculate and you form the concept of ESS. Luckily, it happens that ESS is Nash. Now, you are asking the question, do I go to ESS all the time? And that is what we are asking now. And the theorem which is now we have to prove that ESS is an asymptotically stable fixed point of replicator equation. This makes replicator equation a formidable model, because it matches with your intuition and your desiderata that you want ESS to be something where population goes at the end of the day. So, we have to prove that. There are many ways of proving it. In some way we have proven it here, in a very special case where we have shown that if you have ESS, you basically go there, right? But we want to prove it generally, and there is a very beautiful way of proving it using some concepts of information theory. So I want to make that connection because people were talking about this entropy increasing and all that, but in information theory there is even more fundamental principle whose special case is maximization of entropy. Okay. So I want to discuss that through this. So before I take that jump, I mean I'll take 10 more minutes maximum. If you have any questions, please ask. If you can, I mean, eat up the 10 minutes by asking question, we will not start anything new.
That's very useful.
Yeah. No questions?
Everybody is looking forward.
Saturated.
Everybody is looking forward to
Food, okay. Yeah, we can sort of start.
So what if we include the mutation part?
Yes, there are two different ways. One is you have to decide whether mutants are how rare. For example, here if I wanted to include mutation, you see what is happening here is if I have a trait I cannot create trait j from trait I. If I remains 0 right from the beginning, it will always remain 0 right from the beginning, I mean till the end. So I have to keep a rate of mutation term here, which will sort of say, you know, with what rate some mutations are coming. Maybe I'll put something like, just naively speaking, something like this, with some rate xj is coming in with the plus sign maybe, okay, and with some rate it is going out. I can put those terms. So there are several modifications which make this replicator equation something called replicator mutator equation. That's one way. The other one way which we are going to do tomorrow is, we did not really talk about if I start with the single trait and trait keep on appearing, they will appear through mutation. So somehow I should have a motion of traits in the trait space, trait changing one after other, and somehow from there should be coexistence of two traits. That will mean new species has appeared, right? Only when you have coexistence of two different traits. But that will not come under this. This is microevolution. That will come under sometimes known as mesoevolution or macroevolution. Okay, so we'll come to that. So mutation has these two effects, short term and long term. In maths, I don't know in reality. Yeah. I don't know, probably I just screwed up. No, this one. Yeah, I was just trying to argue that if I get a pure strategy, it will have a form of 0, 1, 0, 0, 0, 1. I mean, all of them will be 0 except 1. So if I have only two strategies, I mean two actions, then form of a pure strategy will be like 0, 1.
That's true for the p vector, right? Not x.
No, again, that's the thing. So again, good that you are getting confused again. X is frequency, which is probability. It can take values only between 0 to 1. So you can think of whatever you did using P. You can think of everything like you are doing in A, but the meaning has changed. So mathematically nothing has changed, but the meaning has entirely changed.
But I thought the information about p is already in the A matrix.
Yes, but then you are tracking dynamics of X, not P. This is the equation of X.
Right.
Your P is inside A.
Right.
But I want to know whether this could be this being 0 when this is Nash. Is this a fixed point? My question I'm asking is, if I give you A matrix and I ask, because A matrix has P implicitly, ultimately you have numbers. I'm asking, given that matrix, there will be Nash. If I have Nash, now I'm asking, please tell me whether that Nash is going to be a fixed point or not. And I'm arguing that if Nash is pure, then that will be given by a vector which has everything 0 but one of them being 1. Because that's what pure strategy means. Again, I'm using the word strategy, but these are now states, right? So you see, when I wrote this, you could have asked the same question. Why are you doing this? I mean, this is not strategy. But mathematically nothing changes because this is the protocol of finding Nash.
This, when you say x is a pure vector, it's in terms of this mu matrix.
It's in the terms of frequency, but it's as if it's a mixed strategy because mathematically nothing changes. Because you see, I am so used to all this, I keep on messing it up, but I know what I'm doing. But of course, you are right, I should be very careful when I'm interacting like this. I agree, but yeah, exactly, that's the point.
So, here like there is some relation between P and X because the information for Xi we are given.
Yes.
But how are we interpreting?
There is no relation between P and X per se. The relation comes through how X changes because the information of P is inside A.
But this information in A, how are we getting that? Like
We don't know.
we don't know.
Because you see, ultimately you will have to find everything experimentally. At the level of mathematics, we are saying, well, there is some underlying matrix U. Should I know that, I can create an A. Ultimately, A is some set of numbers. How to get numbers, it probably is humongously more difficult. In fact, I think impossible to get the U matrix. It is much easier probably to get directly A matrix by actually measuring, by picking the particular traits and finding out what is their fitness value, etc. So I would probably directly find A, but definitionally there is sketch.
So in A, A is just in a sense like it's made of P. So we are not actually finding P in any.
We are never finding P anywhere.
Okay, so we are just finding A.
Yes.
Okay.
Our entire definition, etc., has now transferred to defining EFS, Nash, everything using A.
Okay.
We no longer work with U. But it is consistent because what we just showed. And as I said, that when I do all this jugglery in the context of A, I no longer call EFS as strategy, I call it a state. When I calculate Nash equilibrium, I don't call Nash equilibrium strategy, I call it Nash equilibrium state. So if you use the word state explicitly, you are making sure you are working in the frequency paradigm. But the correspondence remains. Nash thing is only formal, ESS thing, there is a straightforward connection. Yeah.
So is there a common fixed point for all the exercises? And
What do you mean by common fixed points?
so like here in the 0, 1,
Huh.
the fixed point will be for the x1 method.
No, that's not how you calculate fixed points. If I write down an n-dimensional differential equation, fixed point means simultaneously right hand side of all the xi's dots have to go to 0. It does not make sense to say that one xi has gone to 0, other one has not gone to 0, then I can still call it as a fixed point. That's not the definition. Because at the end of the day, you are talking of system as a whole. A point is designated by all possible coordinates. Fixed point means it's fixed. If I'm there, I'm there. I don't move. I cannot move in any direction. If I do not move in any direction, it means in every direction, xi dot is 0. And hence that question is not meaningful because your definition of fixed point is not correct. Yeah.
So, like in K, we have like the payoffs for each of the strategies interacting. Right?
Yes.
So the strategies, but in a mixed strategy, like the strategies are probability.
No. Once we have already, yes, strategies are mixed strategies, so probability, yes. Then
So are those discrete? Like you have like again
the way we have picked up there is because if we are writing a finite matrix, of course there is.
Yeah.
But need not have been. It would have been much more complicated. If I have a continuous set of strategies, one could work, but then any summation etc. won't work. I have to work with the integrals around it. That's all.
But here, like we have a set of probabilities which are like
Yes. We have, technically speaking, we have probability mass function because I have discrete support. If I were working with continuous, I would have PDF. I would have to have a probability distribution function. That's the only technical change, but that screws up sort of everything. And it becomes very hard to write down equation for them. In fact, it is an interesting question whether Nash equilibrium exists if your pure strategy is continuous. So there are extensions of Nash's theorem, where if the strategy set is compact and all, Nash will still exist.
What is the meaning of pure statistics?
You see, let's say our height, right? So every step of my height is a strategy, but it can continuously change. So I cannot write down now as a matrix that height 10 meter, height 2 meter, height 5 meter. Height can be anything. So it's a continuous set, right? So if it's a continuous set, whether your dash equilibrium exists or not, that's a question. And it's not always going to exist unless you put some constraints on all. Yeah.
So, let's say we found a stable fixed point for this set of differential equations
Yes.
that wasn't at one of the coordinates.
Yes.
So would that imply that there is no ESS?
No.
Uh,
No. You see all. Why are you saying that?
because when I started this state, where I have different fractions of each strategy, I'll stay at that state. So I'm not approaching the state where the entire population is taken over by a particular strategy.
Okay, so actually what happens is now so just like when you use the format framework of P's and U's, and you talked about mixed ESS strategy, here you will talk about mixed ESS state. So you will be saying, if my population is in a certain mixture, then if I deviate from that mixture, I'll come back to that mixture. You now have to differentiate between two takes on this X frequency. One is called monomorphic view, the other one is called polymorphic view. The monomorphic view is you have single population where every individual can take two of the strategies. And the polymorphic view is you basically have pure strategic individuals present in different proportions. So when we are in the frequency thing, we have a polymorphic view of the population. When we are strategy sense, we can have both monomorphic and polymorphic view depending on how we view it. But here we have sort of fixed ourselves into reality, and the reality is I have a population with different fractions of certain traits. I really cannot now talk about a single individual able to take both the strategies. That has no meaning in it.
Sir, so P is a mixed strategy.
Yes. My suggestion is now forget about P. Practically, that's what it entails to. That P has no meaning now. Now everything is this equation. Somehow one has to find A and calculate fitness values, compare fitness values, and see where it goes. You have to show that the fixed points of this equation corresponds to Nash, corresponds to ESS and all that. Nash we have already shown, ESS we will show in a little fancy. So P thing you can find. And once you start quote unquote working on all this, sorry I'm taking too much time, we should stop. Once you start working on all this, that's the view you basically took. Now you basically forget whatever all was. But conceptually you have to be clear. Because if there are conceptual questions, for example, you can think about it. Recently, we uploaded a paper on that. If you want to calculate ESS, Nash, etc., in asymmetric games, it is very non-trivial. There are too many mathematical catches. Because you can talk about two populations playing, you can talk about ESS, but how to define all. So it becomes non-trivial.